So there's things called special right triangles. All right, so you have the 45, 45, 90, and the 30, 60, 90 special right triangles. The first one we're going to deal with is the 45, 45, 90 triangles. Now, when you look at these, this is the template for it, meaning that these two sides are just x, or that they are congruent. And the third side, the hypotenuse, is taking this x and putting it next to a square rooted 2. So, this is how you solve whenever you know either the hypotenuse or you know one of the sides. So if you know the hypotenuse, right here, they're in the same spot. So we had to set 12 equal to x square root 2. This is what I'm going to do. I'm going to set 12 equal to x square root 2. Now we want to get the x by itself, so we have to divide both sides by the square root of 2. This gives me x equals 12 over the square root of 2. Now I can't have a square root on the bottom of a fraction. So what you have to do is multiply both the top and bottom by this square root, so that way we can get rid of it. So we multiply the top by square root of 2, the bottom by square root of 2. And what this does is it tells you multiply this 2 and this 2 inside together. So it becomes square root of 4. And this says multiply these two together, so I'm going to take 12 times the square root of 2. What I'm going to do with that is, now what is the square root of 4? The square root of 4 is 2, so it's actually just 12 square root 2 over 2. And that's what I mean by I got rid of the square root, because is now a whole number here. Now if I take this top divided by the bottom, because I can reduce this, this becomes 6 square root 2, meaning the x is 6 square root 2, or that both this side and this side is 6 square root 2. The second one's pretty easy though. If you notice, the 4 is right here, meaning that x equals 4. So if x equals 4, that means that this side is also 4, because it is, once again, is also x. And this side is just 4 square root 2. So try that out.